So there are some very fundamental challenges when deploying artificial intelligence algorithms, especially deep learning algorithms right now. So compute is no longer as big of a challenge as it was a couple of years ago. We know how to design very large compute systems. We have reference architectures, we have systems that were designed explicitly for that purpose. But what is becoming more and more apparent is that data is. We need really large data sets to solve some of the most important problems in artificial intelligence, such as self-driving car, systems that augment doctors in help in their day-to-day activities. What is not trivial for some of those more complex problems is to get labels for the data. So where in self-driving car, labeling is fairly trivial. You can get almost random people from the street and ask them to label pedestrians, label cars, label road signs, and they will be able to do it. So you have low cost of labeling. Labeling brain tumors, labeling galaxies or exoplanets is non-trivial. You need to gain expert labelers in order to do that. So the cost of your data increases dramatically. What generative algorithms and even more widely unsupervised and semi-supervised learning algorithms promise to do is to help address that challenge. The cost of data will decrease because it's fairly trivial to gather unlabeled data. So yes, generative models are a huge promise, and they are suggesting that they can solve a very important problem in artificial intelligence now. Yes, so effectively we've listed quite a few of them earlier. Generative algorithms and even more widely semi-supervised learning algorithms are already becoming a foundation of several very important research disciplines. So natural language processing, the state-of-the-art models used are pre-trained in a semi-unsupervised way. So already models such as BERT or very recent XLNet are semi-supervised, are capable of content generation, are to some extent generative in their nature. So natural language processing, speech recognition, those are all application areas where generative models can contribute tremendously to a wide range of applications, helping blind people read, helping mute people speak. In computer vision, clearly there is a huge opportunity, as we saw with the research from NVIDIA, generating new content, helping artists spark their imagination, but also augment data sets in areas where they are difficult to obtain, like in medical imaging. So at this point of time, the answer is definitely not. They are very simple in their nature. They literally learn a multidimensional surface. And what you do when you use them, you choose a point on that surface. And that's the only thing that they do. That does not account for, that's not creativity. What they can do is they can augment our creativity. They can help us spark our imagination. They can help us automate a process of creating beautiful content or semi-automate it. And this is effectively what the artist community is doing. We've been helping quite a few artists across Europe with some of their sometimes fairly crazy ideas. Like recently we helped set up an art exhibit showing tulips. But it is a process that is overseen and managed by a person. Neural networks by themselves are incapable of being creative. They are just, as we discussed earlier today, function approximators, very computationally expensive, therefore requiring GPU acceleration, function approximators. When you listen to talks by the most established AI experts, so like Jan LeCun, for example, what they will tell you is that we do not understand the path towards what people would like to refer to as general intelligence. Yes, I think this is what you refer to as utopia. We do not know where it is, how to get there. What we know is that there is a huge hill in front of us that is obstructing the view, and that hill is unsupervised learning. And we need to climb that hill in order to see what's behind it. I think that's a very beautiful analogy that I borrowed from one of the talks of Jan LeCun, and that reflects reality. We do not know how to get to general intelligence. So we do not know how to get to those deadly robots that will take over the world. But we know that we need them in one form or another.